I've put it off as long as I can, but I'm afraid it's time to talk about memory. We've been talking about computer programming and not really paying too much attention to where the memory for our variables and our lists and our class instances come from. And we haven't really needed to before. But as our programs start to get a little bit more complicated, we're going to have to understand at least a little bit about how that memory is allocated and where it sits. You've seen me draw boxes and say some memory or some variable references something else. We don't have to go that deep into it, but we need to understand just a little bit about what those references mean and how this memory gets allocated and where it sits. We're going to take a look at some sketches to see if we can make some sense of all this.
We're going to put code on the left and draw memory on the right. In Python, when you declare a variable and give it a value, there is memory allocated for that variable in a block. We don't have to worry about how that memory is managed, but what we do have to know is that there is a block of memory and it is associated with that variable, and that block of memory stores a value. In this case, it stores the value 2. And when you store basic types like numbers and booleans, they get stored right in that block of memory. So if we had another variable y and it had the value 5, it would get its own block of memory associated with y, and it would get the value 5. Now suppose we did something like we assigned the value of x to y, so we said y equals x. When there is an assignment statement, what it does always is it takes the value of the thing on the right, which in this case is the value of the variable x stored in this cell, which is 2, and assigns it to the cell associated with the thing on the left, which is y. The memory associated with y gets assigned to it the value of the thing stored in x, which is 2. So 5 gets replaced with 2. So similarly, now if we went and modified x and set it equal to 9, x would get set to 9. And if we were to print y, it would get the value of y, which is 2, and that would output 2. This is all pretty straightforward and probably not surprising. What gets a little bit interesting is when you have more complex objects, such as lists, strings, or object instances, like we've just been talking about with classes. In all three of those cases, which it turns out is really all one case because strings and lists are implemented with classes, things work a little bit differently. So let's start with strings, but it'll be the same for the other data types, other complex data types, which are object instances. Suppose we set the variable p equal to the string apple. Well, apple is a string, it turns out, is an instance of a class, of the str class that's built into Python. And you can't store an instance of a class inside one of these kinds of memory blocks associated with a variable. When you have a variable, it's really a small memory block. And so all you can store in it is either a basic value, like a number or a boolean, or a reference to an instance of an object. So in this case, what happens is you allocate a block of memory and it gets associated with a variable p, and then you allocate an instance of the string class. So this is really like of type str. And it has in it the value apple. And when you assign it to p, what you're really assigning is a reference to that string instance. This is quite interesting because if we were to then do something that say q, the variable q equals to p, well, what would happen? Q would get associated with a block of memory, and it would get assigned to the value of p. Well, the value of p is the address of this object instance, so q would also get assigned to that same apple. Now this is a little bit tricky because suppose P were to now go modify apple, then Q's version of that string would change, and that would be bad news, right? The Q is supposed to have apple. Suppose P got changed to a pear. Well, let's see what happens. If you set P equal to a pear, will Q change? And the answer is no, because string classes are what are called immutable. That is, once you make an instance of a class, there are no methods in string for actually modifying that instance. Instead, what happens is we've actually made a new instance of a class, and it holds the string pear, and P is modified so it points to pear, and Q safely still points to apple. Now, not all objects are immutable. Let's clear this and look at lists. If we make a list, and we call it, say, F, and we give it the numbers 1, 2, and 3, what's happening in the memory side of things is we've allocated some memory for the variable F. We've allocated memory for an instance of the list class, and we've given it the values 1, 2, and 3 in 3 cells, and we've set F to reference that instance. Now suppose we set G equal to F. Well, as before, we allocate memory for G, and we store in it the value of F, which is a reference to the list containing 1, 2, and 3. Suppose now we go and modify that list, which we can do because the list class is mutable. We might modify the second cell to be 7. If we do that, then 2 is going to get replaced with 7. And if we print G, this is going to result in the list 1, 7, 3, even though we never explicitly modified G. The same thing will happen with our customer class and our transactions or anything else that we define if we make them mutable. That is, if we allow the object to be modified. So if we had made a customer, an instance of a customer, and assigned it to C1, and we set it to Ben, well, then what we'd have here is C1 having a value which is a reference to an instance of the customer class, and it would contain the value Ben, the name Ben in that slot. If we now set C2 equal to C1, well, as before, we would be defining a variable C2 that would reference the same value as C1. And now if we were to go modify C1 by, say, changing the name to something else, say Joe, and then we went and printed C2, sorry, this would get changed to Joe. So if we printed C2, it would print out Joe. So this is not a bug. This is how memory works in Python and, to be honest, in most other languages as well. What it means is you have to be careful and you have to know the difference between signing basic types, like numbers and booleans, and class instances, like strings, lists, and other object instances.